Hi guys, Mr. Bennett here. Today we're going to be looking at graphing, and that's a really important part of the first thing that you need to do is to go and put that function into everything that we do actually requires to look at those graphs. And we, as I've sort of showed you in a lesson in class, that we're going to get about the graph being essential to everything, 3 turning points. So the first question we look at here today is classify the points A, B, C. Looking at there. Okay, so we'd say B goes to the local maximum. Our function, C is a horizontal, we want to match that with what we're expecting to see. It's horizontal because if you start looking at where the tangent is there, first derivative, the tangent would in fact be horizontal. That's going to be 4x. And A is in fact a local mean. Alright, so the other critical points occur sign diagram. Part B. So I was going to draw a sign diagram when f sign diagram 0 will be for f dash, that's what we normally do it for. We've got a common factor, and that will be bring out for x, common factor, and then that would be b squared, c and a. Take 1. That's equal to 0. If we looked at the slope of the tangent at that particular point there, we would know the tangent's going positive. Take 1. So therefore it's going to be plus. You shouldn't hear the slope of the tangent's going to be negative. Right, so if we do a sign diagram for that, continues to be negative. So that there is why we have an inflection point. We know we've got 0 there, and over here -1 is in fact, and we have that. Means it's positive, so therefore we have a local. We also know that our so you can get the shape of this particular curve by looking at just the sign diagram. You know it's increasing. We can get our slope of our tangents from that, or we could use our points over here. So if you do the old-fashioned one, which is when I was at school 20 years ago, before we had little calculators. Now, if we look at places where it's decreasing and increasing, increasing means the slope of the tangent is positive. So let's say we put negative 100 in there, and that would be negative 400 increasing. That would be negative. It's decreasing for negative 99 here. So 3 negatives would give you a negative. And keeping in mind, then we pick up those 2 turning points. It's actually not increasing. That would give me negative. So if we're looking at the increasing 1.5 and plus 1.5. Well, it's increasing so when x is greater than curve over here. X is greater than section here. It's going to be negative. That section there is decreasing. Positive. X is less than. So again, we get the shape of our curve, not equal to, but by looking at, and we'd say it's decreasing, our sign diagram. Our sign diagram tells me where my slope of my tangent greater than it's doing. -2. So that's going to match our curve. 3. All right, now to find these points here. In fact, I think I've stuffed up here. Sense now. With this whole chapter, what they like to do is they're going to teach you every bit of skill as you go. We're going to the big question finally. And so we're going to do all these parts here. So if I get given my function, we'll do f. So now when we come over to looking classify all the stationary points, all the points for f dash, they're all my stationary points of horizontal points. The first thing you must do is √2, derive it. F of x equals, and we also have one at 4x cubed, one at negative √12x. Right, so 8. I mean, if we do that now. My stationary points that go into our calc go to number 1. Now if I put in √2 there, points occur √2 when f dashed of x equals 0. I'm going to get so in other words, what I want to do is I want to factorise. Let's put in √2. Okay, so in other words, 4x cubed number 1 take 12x plus 8 equals 0. I want to find where those stationary points occur. And that gives me -1. The first thing I would probably suggest that you do is with any of these functions. Another critical point is 0. So if we go over here, had a value of 0. That gives the value 3. Obviously, I've been so I can now go for the information. The first thing I'm going to do is I'm going to come to my y equals. I'm going to put that function into my. Over here we know that's -1. I'm going to graph that's -1. Now obviously we have a local max. I had to play around with a window, but I'm looking for a function that has 3 turning points, 3 to the power of 4. Right. So we get our other critical points, our inflection point turning point. So that's double dash function of x when we do that derivative. Screenshot of that. So remember our first derivative gave us. I'll paste that into my gave us. Talk about that afterwards. 4x squared, 4x cubed take 8x. That's going to give me 12x squared. Alright, so that's what I know my function is. It's not a mystery. Obviously we're going to common factor. You should know what your function looks like. You should know what you're looking for. So that will give me. Now, if I'm really having trouble, I could see that I'm having my turning point at -2, and I know my inflection point's at 1. Right, so, but To confirm that, thinking that's been if we go to the calculator into our app, cube root of x, down to polysync 2, x take root 2, that will do the same thing for us, the cube root of. So it's all about making sure we get it right. So we're doing polysync number 1 plus 2. We are looking for a cubic. Right. Once we've derived the other way of solving that would be to say when that's equals 0, make sure that's squared, take 2 equals 0. Right. And then we're going to put the values in. So the x cubed term is 4, x is equal to x squared term is 0, square root of the next term is minus 12. Alright, so the next term there is 8. With that, I need to obviously then do my sign diagram for that. So I'm at negative 2 and 1 and 1 f double dash roots. Alright, so it's okay now to come back to negative over here, and you can now say over here, positive, we don't give marks to factorising. Right, so therefore, again, we get our sign diagram for negative by looking at our function 1 and 1. Now, the key thing, and this is what you're going to investigate in your investigation, is to do the sign diagram. When is a thing going to be convex or concave? Well, convex means the sign diagram is going to be positive. And so you've got negative. So this region here, it's convex. Now, this region here is concave. That region I've got my graph sitting there. So the sign diagram becomes actually I know that's going to be positive there, right? So I know it's decreasing there, so it's going to have a negative 10. If we want to check it algebraically, we pick a value in each of these regions. So if I put 0 in there, and that's the way negative root x, negative root 2. The other way of doing x root 2, this is the old-fashioned way before we had graphic calculators. Negative 100 would be the same. That would be negative, which would give me a positive. If I made that 100 over here, I would probably put that value in here, put say negative 10. So it sort of works out. Let's see if I get a positive value or a negative keeping in mind what our function looks like into here. Right, so let's see what I get. Let's do our graph of our function 100 into there. Because we have to do that in the final part anyway. See if I get a positive value. But because you've got your graph there, I think it's really, that's what we should be using to do that. So that's classifying my stationary points. Now, this is why using your calculator is really important. Right, so I know I've got a local min. Something's playing up here. Sorry about that. Got a local min at negative 2. What's the y coordinate? Well, I'm going to go to my calculator. Scroll down. Just quit out of there. It's a bit strange. Main menu. First time that's happened. Graph that. So keeping in mind with our function, what we're trying to do value. So I'm actually going to do have to graph this thing. So do number 1 fully, negative 2. Right, so I have to show a sketch of this. So I have to show the important features. I don't have to waste time using any algebra or anything like here, somewhere like that. Go straight and use my calculator. Turn around. Got a stationary inflection. It's going to go up there. And turn around. Inflection. It's like a big W, isn't it? Right, critical features I've got in here. Got my local, quite clear you can see it's 0 there, but if you go to your curve, again, I can go to my curve button, and that really useful button, and that's going to be in 0, and it will tell me negative root 2, it's negative 3, negative 1. Okay, so you've got to check it, make sure it's negative root 2, you're not doing the wrong thing. Right, so not negative 2, it's root 2, correct, negative 1. Right, this here is a local negative 3, that's my horizontal inflection point. Now, the next bit I've got to do from that is I've got to do a bit tedious, but you've got to do it. And we know we've got these inflection on my function. Remembering my function was 4x cubed, take 12x plus 8. That's going to give me an answer of 12x squared, at root 2 on 3. Right. Now I didn't find those other factor of 12, did I? So if you go to your calculator, and it's going to be symmetrical again, so if we go to calc and we go to values, take number 1, if we put in there root x plus 2, right, divided by 3. Obviously you're going to have your critical points again when f double dashed of that equals 0.77, right, so that was 1 and negative 1 here. Obviously that is a fraction of double dash that you could actually work out. X. So if we tried to do our math, this is the old-fashioned way of doing it. I would pick a value in each of these regions. Right. So I might go, we can just point what would happen if what we're doing here, x was equal to negative 5, so that would be negative. That would be negative 0.78 positive. Okay, and over here pick say 0, that's going to be negative. That's going to be positive. Negative. Root number 2 value greater than 1, so 10, 0. Positive. Right, so they're our inflection points. Now, when we're talking about increasing and decreasing this, right, so it's going to be decreasing for this region here, that point there, and that region there, we would say that that actually going to be increasing for that region there, because that's concave and that's increasing for that region there. So when we do that, so it's increasing, right, so you'll get that concept, and that's something that's going to come out in your test, increasing for X, so we can say greater than for that negative root 2. Those points here, by the way, are inflection points, and less than is concavity 0. So if we come up to what we had to do there, find and classify any points of inflection. So we do have a point of inflection, right, and it's going to be decreasing, and it's at what we call a non-stationary point of inflection. Non-stationary for X, that means simply that the less than is not equal to 0 root 2. And it's going to be decreasing for X greater than 0, negative less 1 than root 2. Right, and when we start talking about our convex, it's convex in that region. And again, go back to concave in that region there. Go to our calc button. So it's concave, and for X between go to number greater 1 than negative. And we put negative 1 in there, and that negative 2 on root 3. It's negative 16. It does save a lot of time, so you really need to do concave for, you know you're going to get the right answer. Root 2 on 3. Right, convex. So that's my non-stationary inflection. I can now also describe places where it's actually increasing and decreasing. Right, so intervals where it's increasing and decreasing. So we'd say it's decreasing for 2/3 negative. This section here is greater than, and it's increasing for everything else. Right, so you get the idea about the key steps of doing it. Right, so we say the key steps are first derivative gives us our decreasing stationary points, our turning points, our points of horizontal inflection. Our second derivative give us our points where it's going to be less than convex or concave, our inflection point where it changes concavity. Right, and again the third step, main step is to actually draw a diagram and label it. Right, with all the key features. X greater again, these sort of questions are a bit tedious. Now the concavity bit in your exam, right, is so you need to make sure that you know how to do those. Before you're looking at where that, when you're looking from this view going up that way, it's what we say concave. That's convex, and then it goes concave and convex again, and you get that from your second derivative sign diagram. So we would say it's convex for X less than negative 1 and X greater than 1, and it's concave for X greater than negative 1 and less than 1. The last thing that you need to actually do is you need to be able to graph that function showing all these key important bits. Alright, so you need to draw your graph like that. You need to label that as a local min. Oh, let's do it properly. Alright, so you know you get a bit of an idea. So it's going to be a sketch. It's nothing too out there. It needs to be quite clear what you're doing. So we know it goes down here. It's got an inflection point over here somewhere. Goes up like that. So you have to label these points here. So that's a local min at negative 1, negative 27. That is a non-stationary inflection. Inflection, excuse my writing, at negative 1, negative 16. This here is a stationary inflection at 1, negative 3. Okay, this is my x-axis. This is my y-axis on f of x. And you could probably even put an idea of the window there. That's say 10, that's say 5. And obviously you've got your scale there anyway. So that's the key thing I have to do when I'm looking at my graphs. again, I find this ridiculously easy to do because all the information's there for me, and quite often this is the thing that students don't do, and they lose, for a graph. So what am I looking for when I'm actually doing a test? I'm looking for you to get the shape right. I'm looking for you to get the scale right. And then I'm looking for you to label all the important bits. Alright, again, with a graphics calculator, which actually does it for you, all you're really doing is copying. So this is really like a copying section, easy marks in a test. In terms of these questions, I think, years ago when you didn't actually have a graphics calculator, you didn't know what it looked like, you had to just follow through, your first derivative and your second derivative to do that. But nowadays, life should be really, really easy for you. So start with graphing it on your calculator, knowing what it should look like, and then using your graphics calculator to get all your points, as you go along. Alright, there's no marks given for you actually putting a value into the equation and then working out what the answer is. That's just a waste of time. I'll do another video of another question, so I'll leave this one for now. Okay, see ya.